Okay. Hello, students. Good afternoon, everyone. And I'm Guneet Gaur, Associate Professor in the Department of Electronics and Communication Engineering. And in this double sixth semester, electrical engineering in sixth semester, students, I will teach you the subject microcontroller, PLC, and SCADA. Okay, and the theory code for your subject code for the theory is your ACEE 16604A, and this is also a practical subject also, and the subject code for the lab is your ACEE 16608A. Okay, so firstly, we should know about the what is the significance of studying this subject. Firstly, I will discuss the PO's program outcomes, means what will be the benefit to the students after studying this subject, and then what will be the course outcomes, actually what you will learn actually in the real life here, where it will be applicable. And the third point I will discuss with you the its course curriculum. Okay, now I'm going to start with the first slide. Okay, next is here. Firstly, I will start with the program outcomes. Okay, so after studying this subject, the student will be able to means the students, because you are doing the graduation, so graduates will be demonstrated the knowledge of your differential equations, vector calculus, complex variables, matrix theory, probability theory, physics, chemistry, and electrical and electronics engineering. Means engineering electrical part and electronics part will be covered in this subject, like PLC, SCADA. This is your electrical part, and electronics part like microcontroller. So these both electrical and electronics topics will be completed in your this subject. Now the PO2 means, that is POB. Graduates will be demonstrated an ability to identify, formulate, and solve the electrical engineering problems you can solve with the help of your PLC, SCADA, because your subject name is your microcontroller. Then second part is your PLC, and third part is your SCADA. Okay. Now the third program outcome is graduate will be demonstrated an ability to design electrical and electronic circuits, because you know that you can use the electronic components as well as the combination of your electronic and electrical components, and you can also conduct the experiments and interpret data. You can analyze and interpret the data with this after studying this subject. Okay, and the fourth program outcome is here graduates will be demonstrated an ability to design digital and analog systems. Okay, because you can also design the digital and analog. Okay, so these are the four program outcomes. Next outcome is here, fifth outcome is here, graduates will be demonstrated an ability to visualize and work on laboratory. Means you can also work it on the lab, in the lab, and multidisciplinary tasks. Means because you have the knowledge of not only the electrical, you also get the knowledge about the microcontroller, which is basically a electronics. Next program outcome is graduate will be demonstrated skills to use modern engineering tools, software, and equipment to analyze the problems. Means you can also use the softwares and various engineering tools to analyze your electrical and electronics devices. Okay. Next is your next program outcome is graduates will be demonstrated knowledge of professional and ethical responsibilities. Okay, so means you have the knowledge of actually your professional knowledge you will get graduate. Okay, next is your next program outcome is your graduate will be able to communicate effectively in both verbal and written form. Means you can communicate everything in the verbal and the written form also, you will be able. Now, next program outcome is graduate will be shown the understanding of impact of engineering solutions on the society, and also will be aware contemporary issues. Means where it is used, means in the social life where we use these applications of your sorry microcontroller and PLC and SCADA, you will get the understanding of that. Okay, and genuine solutions for that. Next program outcome is sorry, graduate will be developed confidence for self-education and ability for lifelong learning. Means you can also have the confidence to confidence of self-education, and you are able to lifelong learning. You can lifelong learning will be will also helpful. Next program outcome is your graduate will be able to explore the knowledge gained for the participation and succeeding in competitive examinations like GATE, GRE. So in various competitive exams, you can also find the part of your microcontroller, PLC, and SCADA questions in your competitive exams also. So that point of view also, this subject is very important. Next is graduates will be demonstrated their knowledge in effective implementation during their practice of profession of electrical engineering with due regards to the environmental and social concerns. Means you will get the knowledge from the every point of view. You will get the knowledge in the profession of your electrical engineering. So these were the some of the program outcomes, okay, for this subject. Now I will discuss the course outcomes. Means after studying this whole subject, what you will learn in particular this subject. Okay. So I'm going to the next slide. Course outcomes. Okay. So after studying the subject microcontroller, PLC, and SCADA, the students will be get the knowledge, and at the end of the course, first is understand the need and importance of microcontroller. Means what you will understand what is microcontroller and what is the real time applications of microcontroller and how it is different from your microprocessor. Okay, firstly microprocessor comes, then microcontroller comes. So the base for the microcontroller is your microprocessor. Now the course outcome, second course outcome is develop logic so that they are able to develop their programming skills and make assembly language program. So we will do also the 8051 assembly language programming. We will make the programs. Okay. Next is your course outcome 3. Sorry. Interface external devices with the 8051 microcontroller and able to analyze how how they interact with each other. Means how they can interact with each other. We will learn in this subject. Sorry. Now the course outcome 4. Introduction to the Arduino concept. Okay. So you will also learn about the Arduino concepts. What are the various themes and architecture of the Arduino in this subject. Next course outcome is here. Understand the PLCs. You will also understand the PLC programmable logic controller and the simple applications using its ladder logic. Okay. Now last is here understanding the basics of SCADA. Means three portion will be covered. That is your microcontroller, then PLC, and then SCADA. Means you will get the three concepts clear in this understanding the three concepts in this subject, that is microcontroller, PLC, and SCADA. Now next I will show you the course curriculum, that is the syllabus. Okay, so this is the syllabus for the microcontroller. So part number 1 includes the microprocessor introduction part. Part number 1, your whole syllabus is divided into 4 parts. Sorry. Part number 1 is the introduction, and in this we will learn about what is microprocessor and what is the comparison between the microcontroller and a microprocessor. Then 8051 architecture. In that we will also learn about the 8051 microcontroller hardware, its software part, its pin diagram, its ports, various ports, memories, counter timers, then serial data interrupts. So whatever the knowledge about the required knowledge required for the microcontroller, we will get in this part. Okay. Now the part number 2 is your programming part. Okay. Now we will do the programming, means assembly language programming using the 8051 microcontroller. And the main microcontroller use is your 8051. Okay, so in this part number 2 we will cover the mechanics of programming, how we will write the program, what are the various programming tools, techniques, and what are the various instructions we can use, like data moving, logical operations, arithmetic operations, jump and call instructions, then input output programming, stack instructions, means all the instructions we will cover in this part. Okay, now the part number 3. Okay. Now the part number 3 is about the interfacing part. Means how we can interface our microcontroller with the keyboard, with the LCDs, liquid crystal displays, then D2A, E2D, then what are the various assemblers, simulators, then Arduino board. What is the Arduino board? Its pin description, specifications, all will be covered in the part number 3. Okay, now the part number 4. The first three part will be microcontroller based, and the part number 4 includes the PLC and the SCADA. In PLC, we will introduce the PLC, its operation, how it's different from the hardwired system. Then what is the difference between the PLC computer? What are the relay ladder logic? Then ladder runs, process control, basic symbols use. Means what are the various means basics of your programmable logic controller. Okay. Next under this next part is sub part is SCADA, that is supervisory control and data acquisition. Full form for this SCADA is supervisory control and data acquisition. So in this we will read the function of SCADA, then what are the various RTU, that is remote terminal unit details, then control center, what are the control center detail, then communication between how we can communicate between the control center, then control center and remote terminal unit, and applications of SCADA in the Indian power system, and your means communication between the control centers, control center and remote terminal unit, then applications of SCADA system to the Indian power system. So these all are the introductory part about the MCPLC. Okay, so next we will start our syllabus. Uh, uh, Okay, now I will start the first chapter, that is 8051 microcontrollers. Okay, in this chapter we will cover the various topics, like these are the outlines of this chapter, that is what is the microcontroller and the embedded processors. Second is overview of the 8051 family. We will cover these topics. Okay. Next is your, now I will start with the introductory part of this chapter. Firstly, I will discuss about the microcontrollers and embedded processors. Actually, firstly, we have the microprocessors. We have the two terms, microprocessor and microcontroller. Microcontroller is the advancement of the microprocessor. Okay, so actually in this section, actually I will discuss the need of microcontroller and contrast. We will do the comparison between the general purpose microprocessors, such as we have already done, like general purpose microprocessors such as your Pentium, your 8086 processors. Okay, so in this chapter we will also compare general purpose microprocessor with the microcontroller. We also look at the role of, actually what is the role of microcontroller in the embedded market, and how, what criteria is used to choose a microcontroller. Sorry. So first topic is your microcontroller versus your microprocessor. So what is the microcontroller versus general purpose microprocessor? As you can see, general purpose microprocessor contains no RAM, no ROM, and no input output ports. But in case of microcontroller, we have the CPU, that is means microprocessor, RAM, random access memory, ROM, read-only memory, input output ports, timer, ADC, analog to digital converter, and other peripheral. So actually, microprocessor is meant the general purpose microprocessor, such as we know that the where various general purpose microprocessors are like 8086, 80286, 80386, 80486, Pentium. This is from the Intel company. Okay, and for the Motorola, we have 68000, 68010, and these all series are the general purpose microprocessors. So these microprocessors contain no RAM, no ROM, and no input output ports on the chip itself. That's why they are commonly known as your general purpose microprocessors. Next is here, what is the microcontroller? So as you know that general purpose microprocessor has means it has it has no ROM, no RAM, no input output port on the chip itself. So we have to add these components from the external for there to make them functional. So although the addition of external RAM, ROM, input output ports makes these systems bulkier, means microprocessors are bulkier and more expensive. But some advantages are always there. Microprocessors are more flexible because we can add any amount of RAM, ROM, input output ports as we need. So this is actually not case with the microcontroller. Whereas your microcontroller has your fixed amount of RAM, ROM, input output ports, timer, everything on a single chip. Sorry. In other words, we can say processor, the RAM, ROM, input output ports are all are embedded, means everything is on the chip chip on chip itself. Means we have no need to add external memory, external input output or timer. So fixed amount of on-chip ROM, RAM, and number of input output ports actually make them ideal for many applications from the point of view your cost and space. Means where your cost and space are your under consideration, where there we have to use the microcontroller. In many applications like TV remote control, there is no need for computing actually. So we can also use here microcontrollers. Some type of some small size your microcontroller is known as your itty bitty microcontrollers. Yeah, itty bitty processors. Okay. So, these are the some of the various comparison point between the your contrast. We have done the comparison between the microcontroller and your microprocessor. Next is here. Now you can see this is the diagram. As you can see this diagram is for your general purpose microprocessor system. Now you can see RAM, ROM, input output port, timer, serial COM port. These all are external. But in case of the this below diagram shows the microcontroller, means CPU, RAM, ROM, input output, timer, serial communication port. These all are on the chip itself. Okay, so this is the diagram which compare the microprocessor and your microcontroller. And we have the data bus and address bus also. Okay, data bus carries the data and address bus carry the address where we have to fetch the data. Okay, next is here. Okay, now you can see general purpose microprocessor must add RAM, ROM, input output ports, timers externally, as I have already discussed with you. And the microcontroller, in many applications where it space it takes, the power it consumes, the price unit are much more critical issues than the computing power. We will use the microcontroller. Okay, next is here. Now this is the general architecture of a microprocessor. Now you can see In case of microprocessor, we have these various parts. First is your accumulator. Second is your ELU, that is arithmetic logic unit. Third is working registers. Fourth is timing and clock circuit. Next is your program counter, stack pointer. And last is your interrupt circuit. Okay, what is the function of your accumulator? Okay, accumulator is a your is a register. Is a register. Accumulator is a register for doing the operations, mathematical operations, and logical operations, and any other operations. Okay. Next is ALU. ALU is responsible for your all the your arithmetic and logical calculations, and the final result will be stored in the accumulator. Next is working register. There are so many working registers in your microprocessor, like in 8085 B, C, D, E, H, L. These all are the working registers where data have to be stored or fetched. Okay. Next is your interrupt circuit. Okay. Interrupt circuit which handles the various interrupts in a microprocessor. Okay. Next is program counter. Program counter actually tells us the next instruction to be executed. Store the address of the next instruction to be executed. Next is stack pointer. Stack pointer is used for calling the subroutine. Next is your timing and clock circuits. Various operations depends upon the timing and the clock operations. So this block is responsible for that. Next is your, so you can see actually microprocessor alone is not a complete digital computer. If we want to make it as computers, we should add ROM, RAM, EEPROM, double EEPROM, PROM, decoders, video decoders, keyboard, displays, timer counter, peripheral, program peripheral interface, various program interrupt controller, means various IC chips we have to add it from the external point of view. So it's not a completely, we can say, it's a complete digital computer. We have to add so many things. Okay. Next is here, and the various ICs for timer counter, we have to add the IC 8253, for the keyboard display 8279. Similarly, for peripheral interface, we have to add the IC 8255. Then for the interrupter, various interrupter, we have to add the IC 8259. Next is, this is the general architecture of a microcontroller. Okay, so in previous slide we have seen the general architecture of a microprocessor. Now we will do the general architecture of the microcontroller. Okay, so in microcontroller same parts are there. You can see accumulator, same function is performed by these: accumulator, ALU, registers, timing and clock. Yes. Next extra is added is your serial input output ports. Sorry. For serial communication, if you want to transmit and receive your data serially, then you have to use these ports in the microcontroller: serial input output ports. Next is interrupt circuit, that is seen. Next is timer by counter. Okay, timer and counter used in your microcontroller for the counting and generating the delay. Next is memory. So next part which is added in the general architecture of a microcontroller is your memory. Memory can be RAM, ROM, anything. Okay. So this is the general architecture of a microcontroller. Next, so this was the general architecture of a microcontroller. Next, we will do the topic is so you have seen that all the there are so many advantages of adding the peripherals or on-chip peripherals are, because in the case of your microcontroller, we need less hardware. PCB size is small, more reliable, means everything is on the chip, so access time will be small, speed is high, everything is on the single chip. So next we will do the next topics. We will do the microcontrollers for embedded systems. Okay. So firstly, we should know what is embedded system. Embedded actually is a using a microprocessor or microcontroller which only and only do the one task. Means if I will tell you that we have a printer, only the work for the printer is to print the document, nothing else. Okay, mouse is used for the cursor moving of the cursor. Means dedicated task is to be allowed. So embedded product is a that product which do only one task and one task only. So there is only one application software that is typically actually burned into your room. So PC actually, in contrast with the embedded, use the so many applications. So it has RAM memory, operating system, actually which loads the RAM and CPU run them, and PC actually contains the various embedded products. So each one peripheral which is attached to your PC has a microcontroller inside, and it performs only and only one task. For example, if I have a desktop, if keyboard is attached and mouse is attached and printer is attached, so these three are the embedded products because keyboard is used for the typing, mouse is only and only used for the moving of a cursor, and printer is only and only used for the printing. So embedded is a product that uses or that do one task and one task only. Okay. Next is here. What are the various applications of your microcontroller? It can be used in home, office, auto, and every field. Okay. In home appliances like intercom, telephone, security system, garage, door openers, TVs, tuners, VCRs, lighting control, paging, camera, musical systems, machine, toys, exercises, and everything, home computers, everything we use the microcontrollers. Next is in offices, how we can use the microcontroller like telephone, computers, security, fax machines, microwave, copier, printer, color printing, paging. These all are the examples of your microcontroller. Next is your auto. In auto like trip computer, engine control, airbag, like auto braking system, instrumentation, security system, transmission control, entertainment, keyless entry, climate control, like the cellular phone. In all we are using the your microcontroller, and the main microcontroller is here 8051. There are actually three type of microcontroller are main. First is 8051, that is in our syllabus. Second is 8052, and third is 8031. 8031 is your roomless version, means which has no room. Okay, so three family members are there: 8051, which is mostly used; 8052, third is 8031. 8031 is a that version of your microcontroller which has no room, roomless version, that is. Okay. Next is your 86, 8086, or you can say cross 86 series PC embedded application. What are the various that type of PC embedded applications? 86 cross 86 PC embedded applications are actually many manufacturers of general purpose microprocessors actually have targeted their microprocessor for high-end processing speed. But the microcontroller actually at that time is we are inadequate for that task. We should have the more speedy microprocessor need. So when a company targets the general purpose microprocessor for the embedded market, it optimizes the processor used for the embedded system, and very often terms embedded processor and microcontroller are used interchangeably. Means we can use the embedded processor term or microcontroller. These both are interchangeable. We can say microcontroller is also embedded system, we can say. Next is here So actually one of the critical need your embedded system is to decrease actually your power consumption and space. Sorry. But in high performance embedded processors, we have to integrate more functions, more features. So high-end high-end embedded application software cross 86 PCs are saves us money, development time, shortens the development time. Then we have the library of software already written. Then window is already used. So these are the various applications of cross PC 8086, cross 86 PC embedded applications. Next is here, okay, how we can choose a microcontroller. Okay, so for choosing what will be the criteria which is used for choosing a microcontroller. So there are so many microcontrollers, but we will discuss in our syllabus 8-bit microcontroller. And these 8-bit microcontroller are owned by 4 companies: Motorola, Intel, Zilog, Microchip. Motorola's number is 6811. Intel's is 8051, which is the main microcontroller used. Zilog uses the Z8 and Microchip uses the PIC. So there are also 16-bit and 32-bit microcontrollers which are made by various chip makers. Okay. Next is here. So what will be the criteria for choosing a microcontroller? So actually we have to compute the we have to meeting the computing needs actually. So we should follow the we should have to consider the following points. First is speed, packaging, power consumption, then what amount of RAM ROM on chip is required, the number of input output pins and timer, and how we can upgrade higher performance or lower power consumption versions. Then sorry, cost per unit. Okay. Firstly, I will discuss about the speed. So speed, what is the in this criteria we should know about what is the highest speed that a microcontroller supports. On that behalf, we have to choose the microcontroller. If we need more speedy microcontroller, then we have to choose that type of microcontroller which has the high speed. Next is packaging. Packaging, it come in actually 40 pin DIP, that is dual inline package, or QFP, that is quad flat package, and any other packaging. Means which type of packaging we need. On that basis, we also can choose the microcontroller. Third is power consumption. In this, especially critical for the battery powered products, we have to came to know that how much power consumption is required. Next, amount of RAM ROM on chip, how we need. Then next is the number of input output ports and the timers on the chip. Then how easy to upgrade, how we can upgrade that version for the lower power consumption or higher performance. Next, last criteria to choose the microcontroller is cost per unit. So in cost per unit, we should that is important in terms of actually final cost. So cost per unit should be less actually. So these were the some of your point to choose a microcontroller. Now second point to choose the microcontroller is availability of the software development tools, compilers, assembler, debuggers according to that microcontroller that is available or not. Means we should have these all should be under considerations also for that microcontroller which we are choosing. Third is wide availability and reliable sources. Means largest number of actually suppliers are, means availability should be wide and they should be reliable. Microcontroller chip should be reliable. So 8051 has many suppliers like Intel, Atmel, Philips, AMD, Infineon, Metra, DLR Semiconductor, means these all are the companies which provide the microcontroller chips, various type of microcontroller. Next is here. So I have shown these companies: Intel, Atmel, Philips, Synaptics, Siemens, DLR Semiconductor, and their website, which makes the various types of microcontrollers. These are the some companies which produces a member of the 8051 family, and the website for that is written also here. Okay. Next is here 8051 microcontroller overview. So we will start this topic now in detail with the overview of the 8051 family. Okay, so now overview of the 8051 family topic is going to be start. So in this section, actually, we will see various members of 8051 family of your microcontrollers and their internal features will be done in this topic. And also we will see what are the various different manufacturers of your 8051 and what type of the products they are making. So firstly, 8051 microcontroller. Actually, this microcontroller is given by your Intel company. Okay, and this is referred as your MCS51, and it is given in the 1981. It is a 8-bit processor. It means 8-bit data at a time can be handled. And the various features of your 8051 is it has the 128 bytes of RAM, 4 kilobytes of on-chip ROM, 2 timers in the 8051, 1 serial port, then 4 input-output ports, and each having the 8-bit bytes. Means 4 ports, 1 port is of your 8-bit. So 32 pins for the input-output operations. Next is 6 interrupt are there in case of your 8051. These are the standard features of your 8051. 8051 actually is a widely popular your microcontroller. To make and market any flavor of 8051 is also popular. But all are same, remaining the code compatible. Means these all are the code compatible. Only the difference is in RAM, ROM, timer, means in all these specifications. Otherwise, they all are code compatible. Okay, so means 8051 became widely popular after the Intel allowed other manufacturers to make and market any flavor of 8051. So this has led to many versions of 8051 with different speeds, amount of on-chip ROM, and so on. So these were the some of the features which I have discussed: ROM, RAM, timer, input out pins, port, then interrupt sources. Are that these are the standard features of your 8051. Now next diagram shows the 8051 microcontroller block diagram. This is the block diagram, or you can say this is the architecture. So you can see in this interrupt control, ways interrupts will be handled. Also, external interrupts are there also. On chip ROM is also there. On chip RAM. There are 2 timers: timer 0, timer 1, and counter also. CPU, central processing unit. Oscillator means crystal oscillator is used, and which generates the 11.059 megahertz frequency. Microcontroller works on that frequency. Then is bus control, means every bus, address bus, data bus, control bus will be controlled by this. Then 4 input output ports, P0, P1, P2, P3. I have already discussed. And each is your 8 bit. So total 88 into 4 is 32 pins. And these first two ports are used as your address or data. Address as well as data. Next is serial communication. If you want to do, then serial port is there, and 2 pins. For transmission we will use TXT pin, and for receiving we will use RXT pin. Okay, so this is the inside the 8051 microcontroller block diagram. So next family member is actually 8051 actually is the subset of 8052. 8031 is ROM-less version of 8051 as already discussed with you. So we have to add external ROM to it. If we have to add external ROM, then we will lose the 2 ports. Means we, as you can see in this, we have 4 ports. 2 ports will be used for the adding the external your ROM. So these are the compiled features of your 8051 family members. ROM in case of 8051 is 4K, whereas in case of 8052 it is 8K, and 8031 0K. RAM 128 bytes, 256 bytes, 128 bytes. Timer in case of 8051 is 2, 8052 in 8052 is 3, then in 8031 is 2. Input output pins, because there are 4 ports and each port is 8-bit bytes, so 32 pins. 8 into 4 is 32 pins. Next, serial port. One serial port is in all the family members. Interrupt sources means how many interrupts are there in 8051 is 6, in 8052 it's 8, and in 8031 it's 6. So this is the comparison of 8051 family member. In the next lecture, we will do the various 8051 microcontrollers.